In this video, we're going to talk about how to solve absolute value inequalities. So it kind of works the same way, but we have to be careful and pay attention to a few things. So still want to isolate the absolute value first. That's going to be your first step, just like with absolute value equations. But now, because it's an inequality, we have to pay attention to whether it's less than or equal to, or if it's greater than or equal to. So this first one is less than or equal. Well, it's just strictly less than. So if it's less than, what's going to happen is we're going to create a compound inequality. So in that first one, we have absolute value of x minus 2 is less than 5. Remember, we said absolute value could be positive or negative. So we're saying that this statement, absolute value x minus 2 is less than 5, is equivalent to x minus 2 being wedged between that positive 5 and that negative 5. So that's going to be your setup. And then we're just going to solve it inside out like we have been doing with compound inequalities. We're going to add 2 to all sides. That's going to zero out that 2 in the middle, so we're left with just the x. And then we're going to have negative 3 and then 7. So our inequality is going to say negative 3 is less than x is less than 7. Inequality notation, negative 3 is less than x is less than 7. Graph, open circles at negative 3 and 7. And we are including everything between, so we're going to shade between. Interval notation, negative 3 and 7 both have parentheses. Let's do another one. Let's get down to example 3. So in example 3, we've got absolute value of 3x minus 4 is less than or equal to 8. So it's a less than or equal to, but it's going to function the same way. That absolute value stuff is going to be wedged between negative 8 and positive 8. So our compound inequality is going to say negative 8 is less than or equal to 3x minus 4, which is less than or equal to 8. We're going to add 4 to all sides. So to the middle, 0 is out. We're left with 3x in the middle. On the left, we're going to be left with a negative 4. On the right, we're going to have a 12. And then we're going to divide everything by 3. So I'm going to get negative 4 thirds is less than or equal to x, which is less than or equal to 4. So that's my inequality notation. So negative 4 thirds is negative 1 and a third. So I have a solid dot there and a solid dot at 4, and we are shading between. Okay, so now let's get down to example 4. So we have negative 3 plus 4, absolute value 2x minus 6 is less than or equal to 13. So we're going to have to do some fancy math. We've got to get that absolute value by itself first before we can create the compound inequality. So we're going to peel the layers away. So this negative 3 we're going to have to add it to both sides. Okay, so we're going to peel that layer off. That leaves us with 4 times the absolute value of 2x minus 6. That's less than or equal to 16. And then we're going to divide by 4. So we have absolute value 2x minus 6 is less than or equal to 4. And this is where we're going to create that compound inequality because it's a less than. So we're going to have 2x minus 6 wedged between negative 4 and 4. We're going to add 6 to the middle and the sides. So we're going to have 2 is less than or equal to 2x, which is less than or equal to 10. And then we're going to divide everything by 2. And we get 1 is less than or equal to x, which is less than or equal to 5. So there's my interval notation. 1 less than or equal to x is less than or equal to 5. Oh, sorry, that's my inequality notation. Interval notation is going to be a bracket on the 1 and the 5. And then we're going to have a closed circle at 1, closed circle at 5, and we're going to shade in between. So now we've looked at less than and less than and equal to. Let's look at greater than. So if I'm looking at greater than, we're going to have to rewrite this as two separate inequalities joined by an or. So we're going to have the expression is less than negative a, or the expression is greater than a. So we're going to keep it, and then we're going to flip and then make it negative. So let's look at an example. Example 2, we have absolute value 2x plus 1 is greater than or equal to 7. So this is going to be an OR problem. So we're going to have 2x plus 1 is greater than or equal to 7. Or we're going to say 2x plus 1 is less than or equal to negative 7. Okay, here's the why. Why do we do that? Remember when we talked about absolute value, we said this stuff is either going to be positive, right? Or the stuff inside would end up being negative. So I could think about it as a negative parentheses 2x plus 1 greater than or equal to 7. Well, if I divide everything by negative 1, what happens when I divide by negative? I flip that inequality to get the negative 7. So instead of going through that process, we can just go straight to it. We can write it as is, dropping that absolute value, or we could think about it as the stuff inside of the absolute value less than or equal to, where we flip that inequality, and then the negative 7. All right, so here's my setup. I'm going to solve both of them. I'm going to subtract 1 from both sides. So I'm going to get 2x is greater than or equal to 6, divided by 2. So that means x is greater than or equal to 3. On the other one, I'm going to subtract 1. So I get 2x is less than or equal to negative 8, divided by 2. And x is less than or equal to negative 4. So inequality notation is going to include both of those. I'm going to say x is less than or equal to negative 4, or x is greater than or equal to 3. So either of those will satisfy the original inequality. Negative 4 is going to have a solid dot shaded to the left, because we're looking at less than or equal to. And then we're going to have a solid dot on 3 shaded to the right, because that says x is greater than or equal to. So here's our interval notation. Remember, this number line goes from negative infinity to infinity. So this first inequality can be written as negative infinity to negative 4. I'm using a bracket on the negative 4, but remember, infinities and negative infinities have parentheses. And then we would say or. And that second piece of the graph is a bracket 3 to infinity. Okay, so if it is greater than or equal to, we're writing this as an or, so we have two different inequalities to solve. If it's less than or equal to, it's really an and problem, so it's always going to be shaded between. Let's do another one. So we've done example 3, we've done example 4. Let's look at example 5. So we have 2 times the absolute value of 3x plus 1, and then minus 7 is greater than 9. We've got to do some work. We're going to add 7 to both sides. So I have 2 absolute value, 3x plus 1 is greater than 16, and then we're dividing everything by 2. So I have absolute value, 3x plus 1 is greater than 8. This is an OR problem because of that greater than. So I'm going to solve 3x plus 1 is greater than 8, or 3x plus 1. I flip the inequality and I change the sign to negative 8. And then I've got 2 problems to solve. So I'm going to subtract 1 from both sides. So I have 3x is greater than 7 divided by 3. So I'm going to get x is greater than 7/3. Or, other one, subtract 1. So I have 3x is less than negative 9 divided by the positive 3. So I'm going to get x is less than negative 3. You can make this a little bit smaller. So inequality notation, x is less than -3. I like to write my smaller one first, or x is greater than 7/3. So I'm going to go to my graph. -3 is going to have an open circle shaded to the left. Remember, this side goes to negative infinity. And then 7/3 is really 2 1/3. So I'm going to have a circle somewhere around 2 1/3 shaded to the right. And this goes to positive infinity. Interval notation goes from negative infinity to -3, parentheses on both, or positive 7/3 to infinity, parentheses. So let's look at it. Try it on your own. This is where you may want to pause the video, try it, come back, check your answer. So I've got absolute value x plus 6 is greater than 3. So this is going to be an OR problem. So I'm going to have x plus 6 is greater than 3, or x plus 6 is less than -3. Subtract 6 from both sides. So I have x is greater than -3, or subtract 6 from both sides. I'm going to get x is less than -9. So my inequality notation, I'm going to have x is less than -9, or x is greater than -3. So notice with the OR problems, we're always shading out on the ends. So somewhere like over here and over here. So -9, open circle shaded to the left. This guy goes to negative infinity. -3, open circle shaded to the right, which this side would end up eventually heading to positive infinity. Interval notation, it's going to go from negative infinity to -9, parentheses, or we're going to go -3 to infinity and parentheses on everything. Okay, notice again, shading on the outsides with OR problems. That next one, we have absolute value 2x minus 5 is less than or equal to 9. So this is a less than problem, so we're going to create the compound inequality. So we have 2x minus 5 is going to be wedged between positive 9 and -9. So we're going to add 5 to both sides. So I have 2x in the middle, and that's going to be between -4 and 14, and then we're going to divide by 2. So we're going to get -2 is less than or equal to x, which is less than or equal to 7. Inequality notation is -2 is less than or equal to x, which is less than or equal to 7. My graph is going to have closed circles at -2 and 7. And since x is between, notice the inequalities are pointing the same way. Then we're shading in between. And then interval notation, we'll use brackets on -2 and 7. So it's going to be bracket -2, comma, 7, bracket. The last thing I want to mention is back at the beginning of this section, part 4, I like to call these special cases because they don't happen very often. So let's say we have a problem. Maybe we've isolated the absolute value. We have 2x minus 5, and that's less than -7. Okay, so this is going to be a special case. You have to really think about what this means. Absolute value less than -7. Well, that's never going to happen because absolute value is always going to be a positive. And can a positive ever be less than a negative? No. So that means there's no solution to that. There's no value of x that would satisfy that. So I call that a special case. Special cases don't happen very often. Another one, what if that inequality had been flipped? What if it would have been a greater than or a greater than or equal to -7? So think about what it means. We have a positive number, and that's going to be greater than or equal to a negative number. That's always true. So then the solution would be all real numbers. And one way we could write all real numbers, interval notation would be negative infinity to infinity. And if you're thinking about that number line, You're just going to shade that whole thing. Everything would work there. So those are the two special cases that could occur.